So today I will present you KokkosComm. That is a work done by mostly by Gabriel, Nicole, Carl, Cedric, and Yann, Stephen, Mark, and Cedric. I am Hugo Taboada, but the one that really work on. So it's a joint work with CA, Sandia, and Tennessee Technological University. So I will begin by saying, so what is Kokkos? Maybe you don't know, I hope yes. Kokkos is a performance portability programming ecosystem. It is part of, as a building block of various application like Trinos, Betsy, Lamps, or Kavana, and it's open source. Right now, it's part of the Linux Foundation from the High Performance Software Foundation project. Here at the right, you can see the member of this High Performance Software Foundation, and here you can see some of projects that are already on this foundation. So Slack, Alex, and so on. So what is Kokkos? How does it work? It's quite it's relatively simple. It's rely on simple parallel primitive like parallel for, parallel reduce, parallel scan. It works mostly on multidimensional data structure. That in Kokkos we call it a view. The views can be layout right or layout left. Here we can see what it is. If we have a layout right view, it's a row major view. The values that will be on sequential on the memory will be by row, and if it's a layout left, it will by column, and it's really important because when we are on a CPU space, what we call here O space, we will need to have this kind of view, and if you are on a GPU, we will need to have this kind of view, because for cache it's better to have this views, and for coalesced access it's better to have this kind of view. So the view we can also have subviews. That is, if you want have one column, for example, we will take first column of A, it's a subview, and we will take a view that will be subview of contiguous. So what Kokkos have not or not have is distributed computing primitives. So right now, the applications that are based on Kokkos must rely on external framework or for distributed computing. Generally, it relies on MPI, nickel, and so on. It also exists like a Pegas that is called Kokkos Remote Spaces that we will not handle here. And the challenges for the programmers is to handle if the MPI is GPU aware, if we have how do we have to copy the views, if the views are contiguous or not, and if maybe if the view is not continuous, do we have to send multiple small contiguous chains, or do you have to pack all the chains to send a big continuous chain? We don't know. But it's on Kokkos projects, over Kokkos projects, we have a lot of duplication code across this project, because everyone is making his own distributed kind of programming model. So, as I said before, the motivation is how to communicate a Kokkos view between two EuroMPI processes. So if MPI is not GPU aware, or if MPI is GPU aware, if MPI is not GPU aware, we will probably want to send the data to the GPU, to the CPU, and then we go to the NIC and the other NIC, and we will have to do a copy. If the MPI is GPU aware or GPU direct, the data will be sent directly from GPU to the other GPU without passing from the CPU memory, so we don't have to copy. So how do we leverage that with Kokkos view? Because we can have a lot of kind of view with different layout, different, if the view is on memory space on CPU or memory space on GPU, we will have a lot of different, it's a combinatorial problem. We will have a lot of different how to say, kind of things to do. Let's say that. We also have to take into account some Kokkos specificities that I already explained. The layout of memory, and if the memory are continuous or not. And we also want to know how to deal with asynchronous execution, because when you are doing Kokkos, everything is asynchronous. So if you run if you do a send and then you run a kernel, when do you have to fence to be sure that you can use the buffer that you receive and stuff like that. So some related words. Here we can see Kokkos, that is how Linux handle distributed memory, distributed memory. So it's an MPI abstraction, and that it not handle the Kokkos view directly. And after that, we also have some custom implementation in the user application, Cabana, that is transport particle for handling particles, lamps, and so on. Everyone is doing their own stuff, but everyone is using Kokkos. So our goal is to unify this what they are doing. So we also have EuroMPI that is from TTU, and I think it was a paper from last EuroMPI or 2 years ago that is to send a view using MPI. So if to have inside MPI implementation called EuroMPI, how to send a Kokkos, but it's not what we want to do. So I will introduce you what is KokkosComm. So it's a collaborative project between CA, Sandia, and Tennessee Technical University, and other people, Rich, and a lot of people are working with us, and you are welcome. And we want to provide an unified interface for distributed computing with Kokkos. This work is a work in progress. It's only begun in March 2024. So, and the short-term goals of the project is to address the compatibility of to address Kokkos plus MPI interoperability. Simplify the usage of all the frameworks that use Kokkos and want to do distributed memory computing. We want to handle error-prone cases and to be compatible with the MPI. So we want to guarantee performance portability across heterogeneous hardware. And as I said, we will have combinatorial choices. So we want to automatically choose the best strategy to extend the view view that is a GPU view or a CPU view, you want to use the best choice. So we want to simplify the API, and so we cannot follow strictly the MPI semantics. We probably have some Kokkos distributed semantics, but we want to be interoperable with MPI. But we can also use Nickel, Rocker, Glue, Portal directly. Why not? And leverage and modern C++ feature. So it's templated. So if failed at compilation, it will be the best for us. At the longer term, we want to be extensible. So as I said, to be compatible with MPI, local portals, other communication stuff, to provide semantics, asynchronous semantics for send and receive. We do not want to have blocking send, blocking receive, and so on. We only want to have asynchronous stuff, and we rely on some specific collectives. And after that, we want to overlap communication with the data transformation. For example, if you send a data from a CPU to a GPU and you plan to continue to a GPU, maybe you can send and switch the layout of the memory on the fly. And we also plan to explore modern approaches for MPI, API, and C++. So to use multidimensional data like MDSpan and express dependencies between operations with P2300, I think. That is the execution sender receiver model. That is what C++ plans to do to standardize task program. So we also want to see how to do some communication with this kind of specific C++ stuff. Here is one little example just to show you what the API can be. Here it's a little broadcast. We have a request here, so we can broadcast on execution space. Here it's the handle. It's like it's a KokkosComm handle that is not written here, but it's like a communicator on API. Then we can do parallel stuff. We wait on the broadcast and we do a gem matrix vector multiplication, and then we can do another collective. It can be like that, but it's a work in progress. It's probably not the final version of the API. We are working on that. And here is probably the most important slide. Is that the KokkosComm development is an open development, so it's time to take pictures. It's in this website. We have a Kokkos Slack to share with you if you have any question and if you want to work with us. We have Quick Telecom. It's open to all, so you are welcome. And we are looking for different communication patterns. We are getting long Scavana patterns, but maybe you have a Kokkos application and you have a pattern that can be interesting to us to know, because if we are designing the API now, maybe it's time to know if some application guys have some specific stuff and want to add it on KokkosComm. So it was a short talk, but thank you for your attention. If you have any question, don't be shy. And if it's a very technical question, maybe it's better to go directly to Slack. Thank you.
So, any questions?
to the talk. Can you maybe restate the motivation why you can't just use MPI with Kokkos, or what's the problem? The question was why we cannot use MPI directly with Kokkos, because in Kokkos you have the Kokkos views, and so the Kokkos view can be a contiguous memory or not, and in MPI you have to handle a contiguous memory, or you do MPI data types, but I think no one do that. Maybe let's see, do that. I think I don't know, but the point of view we have is to be easy for the user point of view, and not for if you have to program it directly with MPI, maybe it will be too difficult for end users that are mostly physicists and numeration people. It's the reason why we have a lot of stuff in MPI that is not really used on applications.
Okay, any other questions? No, let me raise one maybe. With the KokkosComm, you have a lot of communication going on beside the distribution of the original data. Do you have already something which takes the placement of the data into account in terms of topology mapping, maybe to for the communication patterns later on? Or if not,
I don't think we are on this kind of on stuff right now. We plan to do things well, but it's a really young project for now. But I think it's something we plan to see.
Okay.
So still trying to get the data types.
Wait, we need the microphone.
Yeah, so KokkosComm is still trying to actually figure out what the right abstractions are for just communicating. So anything that topologies and advanced stuff like that is I don't even know.
Yeah, it's probably a need for communication.